All right, let's jump right in. We're going to talk about something that sounds super complicated, but I promise it's not. It's called the magnetocaloric effect. Now, don't worry about that big word. It's just a fancy way of describing this really cool link between magnets and heat. And trust me, it could totally change how we keep things cold. First, just think about the refrigerator that's probably humming away in your kitchen right now. It's on all day, every day, and it's using a ton of electricity. And what's worse, the gases it uses to stay cold are actually really potent greenhouse gases if they ever leak out. It works, for sure, but it's not exactly friendly to the planet. So that leads to a pretty big question, right? What if we could reinvent the refrigerator? What if your fridge could be a part of the solution to climate change instead of being part of the problem? Well, this is what it could look like. A magnetic refrigerator. There's no noisy compressor, no harmful gases. Its secret weapon is just magnets. It's all based on a really neat bit of physics. Okay, so how on earth does a magnet make something cold? To get it, we need to talk about three things: magnets, heat, and a little concept called entropy, which is really just a scientific way of saying disorder or randomness. And the core idea here is the magnetocaloric effect. It's actually super straightforward. You take a special material, you put it in a magnetic field, and poof, it heats up. Then you take the magnetic field away and it cools right down. That's it. This direct swap between magnetic energy and heat is the whole key. So why does that happen? Well, it's all about order versus chaos. Inside these materials, you have tiny little magnetic bits, almost like compass needles. Normally, they're all pointing in random directions. Total chaos, high entropy. But when you switch on a strong magnetic field, you force them all to snap into line. They all point the same way. To get that organized, the material has to get rid of its chaotic energy, and it does that by releasing it as heat. And this isn't some brand new discovery. Scientists first noticed this way back in 1881. For a long, long time, it was mostly just a lab trick to get things incredibly cold. But the real game changer came in 1976, when they found a material, gadolinium, that showed a huge effect right around room temperature. Then another discovery in 97 of a colossal effect really kicked off the modern race to build one of these magnetic fridges. Now, here's a crucial detail. Not all of these materials act the same. Some change gradually when you apply the magnet. That's a second-order transition. It's really efficient, but the cooling effect is a little smaller. Others have a really sudden, dramatic change, almost like ice instantly melting. That's first order. It gives you a huge blast of cooling, but it can also waste a little bit of energy in the process. So scientists are always trying to find the perfect balance between that raw cooling power and pure efficiency. So that's the science. We've got a material that heats up and cools down on command. But how do you actually turn that trick into a refrigerator that can keep your drinks cold? It's all done with a really clever four-step dance. Okay, step 1, you slide the material into a magnetic field. It heats up. Step 2, you pump some water past it to wash that heat away. Step 3, you pull the material out of the magnetic field. Instantly, it gets super cold. And finally, step 4, you pump the water past it again. This time, the cold material sucks the heat right out of the water, making the water ice cold. You just repeat that cycle over and over, and you've got continuous cooling. And the benefits here are just massive. First off, it's completely eco-friendly, zero greenhouse gases. It could also be way more energy efficient, saving you a bunch on your electricity bill. And because there's no big clunky compressor, it's practically silent. No more kitchen hum. Plus, with solid parts instead of gases and pumps, it should be way more reliable and last a lot longer. It's a win-win-win. So, if this is all so amazing, why isn't there one in your kitchen right now? Well, the biggest challenge, and where all the research is happening, is finding the absolute perfect material. It's like a global scientific treasure hunt. And there are a few top contenders, but each one has its pros and cons. You've got gadolinium, which is kind of the classic, but it's rare and super expensive. Then there are these lanthanum iron silicon alloys. They have incredible cooling power and are cheaper, but they can be really brittle. You've also got things like hustler alloys, which are low cost, but they waste a bit of energy. It's a real puzzle, trying to get the best of all worlds. So what are these scientists actually looking for? Well, if you were to graph a material's performance, you'd see a peak. The goal is to find a material where that peak is as high as possible for maximum cooling and as wide as possible so it works over a good temperature range. And most importantly, you want that peak to be centered exactly where you need it, like right at room temperature for a fridge. Hitting that perfect sweet spot is the whole game. So, to sum up the big hurdles, researchers are fighting that energy loss we talked about. They're trying to find materials made from cheap, common elements.
They need to make sure these materials are tough enough to last for 20 years of cycling. And they're solving the engineering puzzle of how to get heat in and out of a solid block really, really fast.
But even with all those challenges, the progress being made is incredible, and the potential here is just enormous. We're not just talking about a better kitchen fridge. This is a whole new way to think about managing temperature. There's this quote that just nails it. Magnetic caloric materials are not merely a scientific curiosity. They are a cornerstone for a more sustainable future in thermal management. And that's exactly right. This isn't just a fun science project. It's a foundational piece of technology for a future where we can cool everything, from our homes to our computers to our medical equipment, efficiently and without harming the planet. So as we finish up, it leaves you with a pretty cool thought. With scientists all over the world pushing this technology forward, that silent, super efficient, eco-friendly fridge might be showing up a lot sooner than you think. The only question left is, will your next kitchen run on magnets?